Cool. So in the past few examples, we looked at ways that you can access the mouse and make drawings and stuff like that. I wanted to show you one more technical example that uses a list of points, an array of points that we can draw longer and more complex kinds of shapes. Um, so I've got again, my template set up here. I'm going with window width and window height, which gives me like a full screen sort of view here. And previously, we looked at I can't type, pmouse x and pmouse y, which gave us the previous mouse points, and then of course mouse x and mouse y. But what if we wanted to keep track of more points so that we could draw a much longer kind of line on the screen? To do that, we're going to need to have an array or a list of values, and then we're going to need to modify that array as we work. So I'm going to go ahead and create an empty array called points. So this has no elements in it. And I also am going to just create a variable now called num points. And this is going to be how many points do I want to keep track of? And we can try changing this number and see how it affects the results. And then in our setup, right now, there's no points. And so it's going to have a hard time. It's not going to work, right? Unless we give it some initial values. So I'm going to use a for loop to generate 20 points all in the middle of the screen at the beginning, and then we can update them later as we go. So I'll use a for loop for this. We know we want num points. And then there's a couple ways that we could keep track of those points. One would be to do a two-dimensional array. So we could say points equals an array like this. And then inside that, maybe it's, like 0, 0, 10, 10, etc., 100, 100. And you could keep track of your points this way. This is a list of lists. But I think that's kind of hard to read, a little confusing. But luckily, P5JS has this very helpful vector object. And a vector stores x and y, or x, y, and z if you're doing 3D stuff. It stores all those points in a single object, which makes it really easy to access. So I'm going to say a point equals create vector at width divided by 2, height divided by 2. It's that easy. And then I want to add those to my array, and I can say points.push and add the point to that array. Now, a couple of things to note here. One is I am a huge fan of semantic variables. So I could call point and points whatever, but it becomes really easy to understand that points is multiple points and point singular is one point, num points, all these things, very clear variable names. It makes your code way more readable. It's easier for you. It's easier for other people. So I really recommend, again, like practicing that. It's going to make you really happy when you get used to it. And the other thing you might be asking is like, okay, well, why use this vector object? And the reason is that later we'll see like for animation, but certainly for things like simulation, the vector object gives us a whole bunch of other functions that do fancy math, compute distance and angle that are really helpful. And this object is like really, really useful for games, simulation, and that kind of thing. Okay, so we've got a list of points that we've all put in the middle, and now we'd like to draw a line with that. I'd like to do it only when the mouse changes, though. So I'm going to create an if statement down here and say if mouse x does not equal p mouse x, and if mouse y does not equal p mouse y. So only if the mouse has changed, because otherwise we're going to draw a whole bunch of points in the same spot. And I want to have it be able to keep its length. So then we need to do two things. One, the first, we need to remove the oldest previous point from this list so that we can add a new one. Otherwise, it just gets bigger and bigger and bigger. And maybe that's what you want. But we can do that using the command points.shift. That removes the oldest item from the list. And then we want to make a new point in the mouse position. So point equals create vector at the mouse position. And then again, we have to add it to the array. Just making the point doesn't do anything. So I'm going to say points.push point. Cool. So now only if the mouse has changed position, we add this new point. And then the last thing for us to do is just draw it. And we've looked at the tools that would do this already. I'm going to make it white. You know, I'm going to copy this in just because it's a little long. Yeah, let's just grab this guy. Now at this point, it's not any faster. That's okay. Okay. Stroke stuff. Stroke join changes the edges or the corners of a stroke. So this will make it look a little nicer. And then I'm going to use begin shape and end shape. And then I can use a for loop to go through my list, my array. So I equals 0, I is less than points dot length. That's going to give us all the points in that array. And then I want to grab the current point from this list. And we haven't talked a ton about arrays, but we access it using the index or the position in the array. And that's what this variable I is doing. And then I'm going to use curve vertex because that gives me a really nicer, smooth kind of line. And then to access the X and Y position from a vector, remember this is this vector object, it's not just one number. We can do pt.x and pt.y. And let's try running this. It's a lot. Let's try running it. And now we can see it follows my cursor around. If I don't move, let's see what happens when we remove this. I'll show you. Just comment this out. So now you can see it catches up to me like this, and it puts all the points in that one spot. And maybe that's what you want, but I kind of want it to feel like a snake. So that's why I have this only changing if the mouse position changes. So you can see now it's almost like it's pulling itself around like that, which is pretty cool. Let's make a slightly fancier version. Let's say we want the line to segments to change color as it goes kind of around here. And if you're already like, cool, this is enough, then you can tune out, you can jump to the homework, that's totally fine. But let's look at this one last example together. So I need two color values. I'm going to call them C1. And in fact, again, I'm just going to grab these guys from my example. It's over here that you can't see, just to save you watching me type. So I've got two colors. And then as I go through my for loop, I'm going to keep this and this. So I'm just sort of reorganizing here. I need begin shape and end shape, just like before. Now there's a couple things we want to change. One, we're not going to be able to change the color of this line using begin and end shape. I take that back. We can't use this because we can't change color in the middle of that, which also means curve vertex is out. So instead, we're going to use lines, and we need to be able to get the current point and the previous point in the list. And so to do that, we can say let previous equal points I minus 1, and let current equal points I. Now, the astute among you may be seeing, uh-oh, something bad is going to happen. If we leave this as it is, our index starts at 0. 0 minus 1 is -1. Well, you can't have a -1 index of a list. That doesn't exist, at least not in the JavaScript. So instead, we're going to start at the second point, which is index 1. And that way, then the previous point is the very first point, then it's at 1. And as we walk through, it's always going to be the current point and the one before it. Then we can do a line between previous.x, previous.y, current.x, and current.y. Let's add a stroke color. We'll change the color in a second, but we can at least see it still works. It does basically the same thing. You'll notice the edges are a little more jagged because we're not doing curve vertex, so it's not computing those nice curves for us. But this still looks pretty cool. And now here's the magic. So instead of just using a fixed color, we can change the color relative to where we are in the array. And for that, we'll use map and Lerp Color, two commands that we've talked a little bit about, and let's see how we can use them. So the first thing we need to know is how far through this array we've gotten. And I'm going to use map for this. So the value I'm feeding in is I, that's the position in the array. And that's going to go between 1 and points.length. And then I need the result to be between 0 and 1 for Lerp Color. And then my color, I can now use Lerp Color. The two colors are C1 and C2, and the amount in between those two colors will be this variable, how far. And then I can set my stroke to be C. And let's see if this works. Now, all right, we get this cool rainbow snake as we go around. The first point is always blue. The last point, little segment is orange. And P5JS conveniently computes all the colors in between and gives us this really nice, even sort of thing. Which I don't know, I find this very satisfying. We could try changing the number of points here and see how that looks. So 10 obviously would be much shorter. We can try, I don't think it's going to break it. Let's try 100 points. So now it becomes, if you've ever played the game of Snake, this is probably giving you anxiety. It gets really long, and we can imagine I'm going to risk crashing my browser here. Let's try it. So now there's 500 points. You can see it takes a very long time to work our way through. It's changing color. That's maybe too many, but it's still kind of interesting once you get there. Yeah, it's kind of fun. So, nothing radically different here. It's just applying these ideas of geometry, color, math, with some additional commands, the mouse position, keyboard, stuff like that. And that's really what this project is about, is just creatively thinking about how to use these pieces to make something interactive, visually interesting, and that kind of thing.